So let us discuss about VLANs. So why do we need VLAN? VLAN is used to for segmenting a broadcast domain. That's one critical point. Another one is in order to, so first is we'll discuss about how the purpose of segmenting a broadcast domain. Then we'll see how do we implement the VLANs to segment. Then we'll configure between VLANs, communication between VLANs. How do we achieve those issues will be discussed. So what is the VLAN? The VLAN stands for what? The virtual local area network. That's what we call VLAN. So what is VLAN? You need to make sure that VLAN is a logical. It's not physical, logical grouping of devices. This is the logical grouping of devices as if what? As if they are attached to the same physical network, regardless of their physical location. That's one critical point that we will discuss it in the future. So what is VLAN? It's a logical grouping of devices so that they will communicate as if they are attached to the same network, regardless of their location. That's the key point. The VLANs. So why do we need to create a segment in VLAN? So that we'll have a multiple broadcast domain. So what is a broadcast domain? A broadcast message is a message that is sent to each and every device in that network. So if you have so many multiple messages, broadcast messages will create. So there are so many broadcast messages every time there is some kind of issue regarding. So let us say this is a switch. So you have multiple devices connected to the network. So here we have another switch, and another devices are connected, so on. So if I think you do know that a broadcast message is a message which is sent from here to everybody in the network. So if this PC have also another broadcast message, this will send a broadcast message to everyone. It is just like in a classroom where everybody is talking with loud voice to the classroom members, requesting some kind of information. Just assume what will happen, the kind of chaos that's going to happen in the classroom if everybody talks to everybody in a loud format. That's what we call the broadcast. A broadcast message is a message which is transmitted to everybody. So if everybody, if some of the members of the classroom, if they start talking at the same time with a loud voice, you can assume that the level of misunderstanding that will happen in the class. So that's what we do in the class. So rather than having a very large students in a bigger classroom, we need to have a smaller students in the same classroom so that they will communicate easily. That's what we do with regard to virtual LAN. It is segmenting a physical network into a multiple broadcast domain. So if you have very large, huge number of PCs in a network, you will subdivide them into a smaller components. So each of them will communicate in between those PCs in those networks. So if you have any kind of message to be sent, those messages will be sent only for the members who are in that logical partition. So the broadcast message will be limited in that area. So broadcast messages will not be sent to every PC in the network. It will be sent to those limited members of that VLAN or virtual local area network. So it's a logical separation of devices. So the devices will be logically separated into different or separate networks, even though they are in the same logical network. So why do we need VLAN? So the first one is it is logical segmentation. As we have said, that it's not physical segmentation, logical, because if a single physical network is subdivided into a smaller logical network. The second one is controlling a broadcast message. So a broadcast message, as we have previously said, it's a kind of message which is sent to everyone in the network. So if you have multiple users in the same network, so if multiple PCs try to send a broadcast message at the same time, there will be so many collisions in the network, and the network will become slow, and it's not usually safe from the security perspective. So since the devices are logically separated into smaller groups, so there is no security threat, because everybody will deal with those members in that VLAN only. It cannot communicate with every other PC in the network. And also it will provide you flexibility, because you are not required to be in the same physical location. So rather than being at the physical location, you can perform at different locations. You can have communications. Other one is performance optimization. So because we have a limited broadcast and multicast traffics, so the network will become very efficient, because it's just a smaller number of PCs communicating among themselves. And that's one. An implementation, they are usually implemented in the managed network switch, so that members will be assigned based on some criteria. Let us say either MAC address or port numbers based on specific locations. So why do you can see here how many floors do we have around. So here you have the first floor, you have the second floor, you have the third floor. Previously, how do we configure in the previous format? These three PCs, those PCs in the same floor, in the first floor, will communicate only between themselves. Because those usually if this was on the previous format, all of them would have been in one network. So any broadcast message which is sent from anyone, let us say from the IT department, it will reach to everybody, either in the human resource, in the sales department. Everyone will get the broadcast message. So it is a kind of chaotic environment to send and receive this kind of information. So rather than having this kind of environment, we'll subdivide them into different VLANs. So these groups only will communicate through themselves, because they are the members of IT, even though they are in different floors. Some of them are in the third floor. So this is why we call it a logical. It's not a physical. If you see it physically, those which have been connected to the same switch should have been communicating among themselves, but that's not the case. Even if they are in the in different floors, they can communicate within themselves only, because they are in VLAN 2. So only the members of a VLAN can communicate or even send a broadcast message among themselves. Other groups will communicate in another format, and others will. So this is what we call the logical separation of one physical network. If you see it, all of them are connected by switch. So if your devices are connected by switch, usually they are in one VLAN, so a single VLAN. But the single VLAN can be subdivided, as you can see here. It is subdivided into 3 virtual LANs. They are not actual LANs, but they are virtual. They are virtual. So virtually, we have created 3 VLANs from a single physical local area network. But you can see that, especially if the members of the staffs are in different floor or in different building, you can manage them, you can connect them. For example, IT staff members will be assigned to VLAN 2, human resource members will be assigned to VLAN 3, so they can easily communicate using this one. So, as we have said, VLANs are used for what purpose? Segmenting a LAN into different VLANs. So without the regard, we are not concerned about their physical location. So what do we say VLAN is? VLAN is what? A logical partition of layer 2 networks. It's not layer 3. Since the switches are a layer 2 device, usually we will create multiple VLANs from a single VLAN, a single LAN. So we have a single LAN, that's one big LAN. Why do we need to subdivide the single LAN? Because we have multiple devices in the network. So those multiple devices, because of the broadcast message and security and other issues, we will subdivide them into different groups, logical groups. So those kinds of groups, we call them what? VLANs. So those on the same VLAN will send the broadcast message, will communicate among themselves, and so on. So if the route, if VLANs, for example, if IT members, if they want to communicate with the human resource, or if they want to communicate with the sales, they need to have what? Routers in between them. So communication between VLANs is usually done through what? Through the router, because VLANs are considered different networks. So what was the device that is used to connect different network members? That's the router. So router is the device that's going to connect them. So you can see here, when you look at it, just by looking at the IP, by the physical configuration, it looks like we are in the same VLAN, in the same LAN, one physical LAN, but they are separated using VLAN. So members of VLAN, so these members, the members of VLAN 10, can communicate within themselves. The members of VLAN 20 who are students can communicate with themselves only. The members of VLAN 30, which are guests, can communicate with themselves. So we have created how many VLANs? 3 VLANs. This is VLAN 10, this is VLAN 20, and this is VLAN 30. That is the number. The name of this VLAN is faculty. The name of this VLAN is student. The name of the VLAN 30 is guest. So you can see that we have partitioned a physical LAN into 3 different logical LANs. We have already discussed about their importance, security, cost reduction, better performance, smaller broadcast domains, efficiency, manage. So these are the topics that we have discussed in the previous. There are different types of VLANs. So what are the different types of VLANs? The common ones are that it's a default VLAN. So even if you don't have a VLAN, by default, all the switches are the members of VLAN 1. That's the VLAN 1. So that VLAN, we call it what? Default VLAN. So that was by default, all VLAN, all devices in the network are members of that VLAN. Another VLAN are VLANs that are used for, commonly created for users or devices. We call them the data VLANs. So those data VLANs can be any VLAN. So I think previously we have seen 10, 20, and 30. They are called what kind of VLANs? Data VLANs. Also, we have a native VLAN. So a native VLAN is a VLAN that carries untagged traffic. So this is the common word, untagged traffic. What is untagged traffic? Untagged traffic is a traffic where some switch does not support VLAN. So if those switches or PCs or some devices that does not have a VLAN identification mechanisms, those kinds of devices can communicate through native VLAN. So they don't need a VLAN number, so they can communicate with the native VLAN. And also, there is another VLAN that's called management VLAN. What is a management VLAN? Management VLAN, it is used to carry management traffics. For example, for remote management of switches from different locations, you can manage your switch from remotely from different locations. So those kinds of VLANs are called what? Management VLANs. Well, another one is the VLAN trunk. A VLAN trunk is it's a kind of ports, or the ports which can carry multiple VLANs. You can see this VLAN, they carry multiple VLANs, because if you go from here to go from here to here, you pass through this path. So this is VLAN 20, this is VLAN 10. This can also pass through this one. This can also pass through this VLAN. So these VLANs, these three VLANs, this one, and this one, they are called access VLANs, because they are directly connected to a specific VLAN. But if you see this one, if you see this one and this one, they are not connected to a specific VLAN. In the first place, they are connections between switches. They are not directly connected with end devices or with the PCs. They are directly connection between switch and switch. And also, if you can see from here, these two are also a connection between switch 1 and switch 3. So that's this path, we call it a trunk, that will carry multiple VLANs across a single network. So those kind of VLANs, we call them VLAN trunk. So they can carry more than one VLAN in their And also they are not associated with any VLAN. They are not either they are not VLAN 10, they are not VLAN 20, they are not associated with VLAN 1. So usually they are 802.11q. That's a VLAN trunk protocol. So there are different protocols. I think you do know them that. So one of the protocol that is used by the VLAN trunk protocol is IEEE 802.1q. So how do we control the broadcast domain? So whenever a switch port receives a broadcast frame, so we said that a broadcast frame is a kind of frame. If you send it from here, it will reach to everyone. Everyone will receive that kind of message. That kind of message we call it what? A broadcast message. So usually it creates a chaos as the number of devices increases, because everybody may send broadcast traffic at the same time. So those kinds of things will create collusion in network domain. So VLAN can be used. It will limit broadcast frames. How does it do? Just you will assign. So for example, if VLAN 10 sends a broadcast message, it doesn't reach VLAN 20. It only goes those members of VLAN 10, only for the VLAN that number members. So those kinds of will be controlled by the VLANs. For example, you can see that so previously we said what is the purpose of tagging? The purpose of tagging is whenever you send a VLAN frame or a message through the switch, you'll tag it. So this is what we call tagging, so that you can differentiate between, for example, you can tag it to 10, 20, 30, so that only members of that VLAN member would receive those kinds of values. So we have said that previously what? For example, you can see that this is VLAN 1, this is VLAN 2, this is VLAN 3, this is VLAN 1, VLAN 2, VLAN 3. So, but this one does not have a VLAN connection. So what does it do? It can send untagged message. So without tagging it, you cannot provide any VLAN. So by default, we say that VLAN 1 is what? It is a native VLAN, so that those untagged messages will be sent by those kinds of implementation. So how do we implement? First, you need to know the numbers. I think you have seen previously 10, 20, 30. Why do we use them? Because these numbers are between this range. So those ranges are VLAN numbers. From 1 up to 1004, they are VLANs, which are called the normal range. But sometimes we might include another one. So they are usually configured, they are called extended VLANs. So starting from 1 up to 4096, they are usually used. Anyway, they are called what? Extended VLANs. So how do we create? The first step is what? Creating a VLAN. So in order to create a VLAN, you need to come to the global configuration mode. In the global configuration mode, you'll write the VLAN number. You'll say VLAN like this one. Just you'll say VLAN 20, then you'll provide the name for that VLAN. So you can see here, what is the VLAN 20? VLAN 20 is student. So VLAN 20 is what? Student. So you can see student is a VLAN 20. Then after creating a VLAN, you assign a port to that VLAN. So now previously we have created what? Student VLAN. What was the value for student VLAN? It was 20. Now we're going to assign to student VLAN different ports. So for example, now here you can see that this port, that is F18, this one, this port is assigned to what VLAN? To VLAN 20. So switch port mode is access. You can see that there are two types of modes. So whenever you have a connection between switches, this mode is called what? Trunk. Whenever it is a connection between the PC and the switch, we call it what kind of switch port mode? That's called access mode. So the PC is directly going to access it. So you need to differentiate between these two. So switch port, this one, because it's directly connected with the PC, that's called access mode. So you need to configure that one, and we're going to assign different ports. Will come anyway. The mechanism, the way of assigning switch port to specific VLAN is through this mechanism. So what you'll call the VLAN name, then you'll say access mode, then you'll say specify what? The switch port access VLAN is going to access that VLAN. Sometimes you might change the VLAN. Now, for example, here you are saying no means now that the switch port F18 is not going to access which port? Is not going to access that specific switch port mode. I think previously we have assigned it to VLAN 20. Now we're going to we have revoked its previous values. We can also delete VLAN, so we can delete VLAN. So in order to see VLANs, you'll say show VLAN, then you'll specify the name of the VLAN. So for example, you can say the name of the VLAN is student, so then you can verify your implementation. Sorry. So now you can also, now we are going to configure what? Trunk. Previously we configured what? Which kind of mode? Access mode was, it was an access mode. Now it's a trunk mode. So in the trunk mode, which one do you think is the trunk mode? The trunk mode is this one. All these are access modes because they are directly connected with what? With the PCs. So trunk modes, then you will specify the allowed VLANs on trunk mode, because trunk mode will carry multiple VLANs on it. So you can see on here it's going to carry allowed VLANs are what? 10, 20, 30, 99. So the 99 in this case is what kind of VLAN? Native VLAN. So if it is native VLAN, it's used to carry what kind of information? Untagged information. We can set the same reconfiguration can be done with the previous mechanisms. So another one is sometimes addressing issues can be, for example, PC1 here, the PC1 here, this one, cannot communicate with the server, with this server. Why? Because they are, why do you think they cannot communicate? Yeah, here you can see the IP here. You can see the IP that they don't have the same IP address. So this one is this is 172.172. Here it is 172.17. They are not in the same IP address, so they cannot communicate. Anyway, this is one of the mechanisms of another concept. It's called what? Inter-VLAN routing. Inter-VLAN routing means in our case, we are assuming that what? We are assuming, let us say this is VLAN 10. So this is VLAN 10. Another VLAN which are connected VLAN 20. Another VLAN 30. If you want to communicate these VLANs cannot communicate through the current approach. So if you want to communicate different VLANs among themselves, you need to have a router in between them. So router will connect one VLAN with another VLAN. So that's the concept of inter-VLAN routing. So there are different mechanisms of inter-VLAN routing. So inter-VLAN routing means what? Different VLANs. For example, here you have VLAN 10, then here you have VLAN 13. They can communicate through the router. So that's what we call it inter-VLAN routing. So there are three options for inter-VLAN routing. This is the legacy approach, the one that you see on the picture. That's called the legacy one. And the other one is the router on stick type, which we have here. You can see you have two cables. In the case of router on stick, this cable will become only one. It will be subdivided into sub-interfaces, and also you can use the layer 3 switch using the SVI mode. So this is what kind of approach? This is the legacy approach. You can see you have two cables to communicate. So different VLANs can communicate. One can go from this way and can come back here and can go to the another location. So this is what we call it inter-VLAN routing. So you can communicate among VLANs using router. So the router on stick type, you can see it has one cable. So to communicate from here to here, from here to here will be difficult, as you can see, because it doesn't have two passes. In this case, a single cable, this cable will be divided into different portions based on what? Based on sub-interface. That's what we call it, sub-interface. So you can subdivide it into different numbers. That's what we call it, sub-interface. So this is how we configure it on the switch. So on the switch, you can see that we have how many VLANs? We have VLAN 10, VLAN 13, 30. So they can access different networks. So you can see that on the router how you are going to configure them. So you can see here, this is interface GIG 00. Here in interface GIG 01, you are providing them different IPs. So one of them is it's a kind of VLAN 10. Another one is a kind of VLAN 30. So those kinds of configuration can be configured using the interface inter-VLAN routing mechanism. So, but in this case, you can see here you have only one pass. So it will be a little bit difficult. You are going to create a sub-interface. So all of them here, you can see they are G0. You can see they are gigabit 00. But you have subdivided it based on the network IP. So for example, here you have how many networks? 2. So one of them is going to be 10 because this is 10 network. Another one will be 30 because this is 30 network, and 20 will be another network. So a single the single cable will be subdivided. It's like subdividing a single path into 3 lanes. So this is what we call what? Configuring router on stick. So you can see here this is configuring. So you can see this is dot 10. This is one of them. So this is subdividing a single configuration into